Hey everyone, welcome to the first video of this entire playlist. Uh, we will start with, let's say, orientation in this particular video, lay over some foundation for Web3. And this entire playlist will help you to get full understanding of Web3. We will start with the basics. We will go till whatever I know till now, and then we will also build one or two projects. So this is what the entire playlist will be about. I hope this goes well. The first video, starting with the first video, we will be talking about orientation. So, few points that we will be talking about. Let's say first we will talk it. Sorry, yeah. First we will talk about why blockchain, right? I mean, why did it come into the picture? Why there was a need of something like this? Why it sometimes makes no sense to have such of this kind of thing. And then we will also talk about some of the very fundamentals that we need to understand to just let's say lay the foundation of the entire computation thing, right? So I will write. So let's say second point would be fundamental fundamental things to understand the blockchain, right? The third thing we will be talking about is something, let's say, oh, sorry, yeah, proof of work, right? What is proof of work? This proof of work is something that helps to make the transaction, right? It is nothing but, let's say, when the Bitcoin blockchain was available, this is something that, I mean, you might have heard of miners, right? You might have heard of the lot of computation goes into, let's say, mining a Bitcoin. What is this mining of Bitcoin? This thing, which is proof of work, will lay the foundation of it, right? And why do you need very, let's say, people to set up systems with very high amount of GPU, right? And the systems are very powerful. What do they do it with that power, right? And this is what we will talk about in this particular thing. Cool. So let's start with it. Bit of story time. Why blockchain, right? Why do we need blockchain? So, way back, I mean, see, the currency is not that old, right? The currency is, let's say, 100 years old, not more than that. So, what used to happen before that? That we used to have a barter system, like, right? So, let's say if you give me gold, or I will give you something else in return of it, or whatever you want. Then the government, or let's say the banking thing, came into the picture, and what did they say? The initial logic or the initial founding was that let's say you have gold. So sorry for my diagram. Let's say you have gold. So the amount of cash, okay, the amount of cash that you can say as of now the bank used to print, or what bank used to say basically, if you gold is very hard to handle, right? I mean, very hard to maintain, then you have to break it up and things like that. What bank used to say that in place of this gold, we will give you a paper note that will hold a value. What value will it hold? That, let's say, instead of using, let's say, 10 rupees of gold, I'm just giving an example, you can use a note or currency that has 10 rupees written on it, and it assures the bank or the so sorry, the central agency used to ensure that this thing hold a 10 rupees value, which is nothing but same as 10 rupees of gold. Okay, just a basic understanding of it. But recently, all this changed. Why all this changed? Because, I mean, if you see, there's a central agency, right? There's a central agency, or I would say, yeah, there's a central agency that handles the money. Now they have the power. Cool. So, what they can also do is they can print money. Basically, they can print money. So what happened? First, it was used to it used to be like that the 10 rupees note or currency used to, let's say, maintain this 10 rupees of gold's value, right? But it changed. It changed because the central agency, just giving an example, let's say there's a huge, let's say bank, right? Let's say there are 5 to 10 banks in a country, and some mishap did happen, and all of the banks are about to go bankrupt, right? They don't have money. So what used to happen that the government, I mean, the financial, let's say the entire finance of a country used to be supported, and still it is on the banks, right? Banks are one of the core persons or core important things of the entire financial chain. So government didn't want the banks to go down or go bankrupt. So what they did is they printed more money, right? They printed more money. So what happened of this? What happened because of this? This money came into the market, right? This money came into the market, and when this money came into the market, inflation did happen. So if you don't understand what do I mean by inflation did happen, so let's say if everyone, let's say that if I'm the government, right, and I give every person in this country or whatever country I belong to, I do give everyone instead of 10 rupees, giving them 10 rupees, everyone to everyone I did give 100 rupees, right? For an example. So giving this 100 rupees, what will happen that let's say there's a person P1, okay, what he will say that, hey, I have extra, let's say 90 rupees. Now, if I used to spend, let's say 2 rupees for, let's say, grocery, now I can spend, let's say 8 rupees, right? For an example, because he has a lot of money compared to before, right? And now he has an easy hand to, let's say, give out the money or spend the money. What this will cause is the grocery shop owner will say that, hey, if this guy is paying me 8 rupees, I can also ask this or ask 8 rupees to other person. And hence, this is how inflation happens. Inflation is nothing but the price of things do get increased, or other way if we think of is that the value of currency decreases. The same, let's say, tomato used to come at, let's say, $1, right? But now, let's say the grocery shop is charging us $2. So the tomato is the same, but the value of the currency decreased. You can also take it as the value of the currency decreased or the value of the item increased, whatever. So this is nothing but an inflation. Why did this happen? Because government printed a lot of money and they put it into the market. And now the market, that means we the people, have a lot of money to spend, and hence the prices of the things did increase. Right? This is how inflation works. Cool. So close to, let's say, 2008, what happened? Or recently in 2020, the COVID happened, right? So government did print a lot of money. So what did it cause? It caused a lot of inflation. High, very, very high inflation, right? So this inflation, so let's say in 2008, if you do remember, there was an internet burst, right? Sorry, internet bubble burst or dot-com burst. At this time, what did happen? If you want to actually understand this, you can watch a picture. I will do name it. So now what happens is, at that time, the cryptocurrency, the people who were working on crypto, not cryptocurrency, crypto, they understood that we don't need a central agency here. Why don't we need a central agency? Because agency, why? Because this central agency has a power to decide whom it can lend money to and whom it can borrow money through. So there's a central power. These people have power to decide what will happen and what will be the value. And this can be very bad to the people. So they wanted something which is not handled by any central agency. They wanted something which is handled by itself and the people, right? So this is how a concept of cryptocurrency came into the picture. Now, talking about, if just give me a moment. Yeah. So talking about, so this is why cryptocurrency came into the picture, right? Now, so I think we did understand why cryptocurrency was thought of and came into the picture. So I think that's more than enough for why do we need blockchain. Okay, so not blockchain, I would say. Why do we need cryptocurrency, right? Now coming to the second point, which is fundamental things to understand the blockchain, right? So let's start with here. So the first fundamental things to understand okay, sorry, fundamental things to understand the blockchain. Okay, the first thing that you need to understand is something called hashing. Okay, what is hashing? If you guys do know, then it's well and good. I would like to, but uh, try to make you understand. If you don't, please do have a look here, right? So, what is hashing? Hashing, let's say, so in basic terms, let's say you give it a input, any input, okay? We will talk about what input later. You give it an input, and you have a black box here. If you are a developer, then I mean, I hope you are here because you are a developer and you want to learn Web3. So we have a function, okay? It uses something, okay? It uses something called hashing algorithm, and it gives an output. This output is totally different from the input. What do I mean by totally different? By seeing this output, you won't be able to guess what is this input, right? So why do we need this? First of all, why do we need this? Why do we need to give something an input and want to create an output of it, right? Uh, we will come to this later, and then maybe you can match the dots to understand why do we need this, right? First, we will just talk about what is hashing and why do we need it. I wouldn't say why do we need it. First, we'll just talk about what is hashing, right? So hashing is nothing but you give it an input to a function. It does some hashing algorithm works, right? It does some hashing algorithm works, and it gives you an output, right? What is this? If you have heard of something called SHA-256, this is nothing but an algorithm, a set of code that that changes this input to a output. That output is totally different. We will see what this output is. Let's say we will go to another tab. Let's say, so this is a website, right? We You can have a look here. So here, this is an SHA-256. This website is nothing but using a SHA-256 algorithm. We have different hashing algorithm. Okay, we have different hashing algorithm. This is the most commonly used. What it says is you type an input here. Let's say I do test. Okay. So what you can see, maybe you can see it up here. What it did, I am using something. Just do not, I mean, do not worry about what is this. It is some, we won't talk about this as of now. But you can see output encoding is hex lowercase. What is this hex? We will just talk about it. But if you see here, the main thing is you give it string and it creates something very different out of it. So by looking at this, anyone can't guess what is this, what the input will be, right? So this is nothing but hashing. There's also one more term. If you guys do get confused a bit, there's also a thing called encryption. But encryption here, encryption, CRYPT, is not equal to hashing. This is very important. How this is not equal to hashing, right? And I don't want you guys to get confused because of this between hashing and encryption. Hashing is something you give it an input, the output is obviously, I mean, in encryption too, the input and output is different. This is same in both encryption and hashing. But in hashing, you can't get the input back from the output. You can go just one way. You can go from a normal string or a normal text to a very different output. What I mean is, you can create test from test. You can create this number, but from this number you can't get back and know the test. Okay, but in encryption it is two ways. What do I mean by two ways? Encryption is two ways. That means you can create this output from this input, but you can also get back the original input from this output. Okay, I hope this makes sense. This was the first difference, that in encryption I would create a, let's say, a straight line here. So what a straight line. Maja aa gaya. Okay, in encryption this is two ways, right? This is two ways, but in hashing it is just one way. I hope you now understand what is two way and one way, right? The second difference, this is, I would say, one of the main difference between the hashing and encryption. So don't get confused. Uh, Instead of talking about other differences, I would like to talk about what other properties do hashing has, right? The first thing what you can see, obviously, which I already told, it's one way, right? The second thing is in encryption, same input, same input can give diff output. That means same text, which is, let's say, test, can give different output. Might be possible. I mean, based on the algorithm, it is always not true and not false, right? So based on the algorithm, the same text can give different outputs. But in hashing, the same text gives same output, no matter what. No matter what you do, the same text will give same output always, right? The third thing is, let's say, in this is not a difference, I would say, but this is a property of hashing, that even a small change, a small change in input gives a huge change in output. Okay, what do I mean by that? Let's say this, we have this, right? If I just change E to A, can you see the entire output got changed, right? If I go from this to again E, it entirely changed. So a very small change in the input will change the entire output, right? And the last property I would say as of now is the hash is, let's say, two strings, two different strings. Let's say test and TAST. These are the two different things, or whatever strings, input strings you do consider. Two different input strings can never create a similar hash, right? The hash will be always be unique. Not most of the time. It is very, I would say, defined as of now, that two different or no two different strings can create a single hash. So every hash will be unique. Cool. Now, so we did talk about hashing and encryption. What do we need by encryption? What do we need by hashing? This is something I wanted to talk about before moving to the next part. Now, so now we will come to a page. Now we will come to, as we talked about, what is, I mean, there was algorithm we were talking about, sorry, which is SHA 256, right? What is this SHA 256? What is this, let's say, algorithm, right? We'll come here. So you can come to this page, right? Which is nothing but the same page, EMN17, whatever. And we are using SHA 256. As I already showed you, this test creates this output. Now, let me clear why is it called 256? What is this output and how do we get this from this, right? I can't talk about how a binary output or what is the inner algorithm that converts or creates this, right? Because anyone don't, I mean, people do know, but it is not predictable. But what I can talk about is, why do we have this 256 here? And from, and if we have this 256, why do we have this thing? I mean, this is a string. And if you also see, even if I do, let's say, this is, let's say 64, characters long, right? Even if I do any number of changes, even the string is like infinite, the length of the string is not increasing here. It is still 64, right? So how do we get this? So talking about what, the 256 here is nothing but the number of bits. What is bit? If you know, then it's really good. But if you don't, then bit is nothing but the atomic thing of entire computer science, right? 0 and 1. There are only two bits, which is 0 and 1. So this one thing is nothing but called a bit. This is a bit, this is a bit, right? So a single number which can only be from 0 and 1, we call it a bit. Now what is a byte? Byte is nothing but 8 bits, right? So combination of 8 bits, which is, let's say, 1 2 3 4 5 6 7 8, this is nothing but a byte. Okay, the combination of 8 bit is a byte. Now if we go back, what did I say? It's 256. So the output, the binary output, okay, not the normal output, the binary output of this particular text is nothing but 256 bits. 256 bits is, let's say, the 0 time 256 times. Okay, so some combination, not 0, I would say, let's say 0 1 1 0 1 0 1 and 0 0 and so on. Okay, so this particular string creates something, not this is not exact, but yeah, this creates something, a binary, let's say string, not, let's say, a binary number which is 256 bits long. What is 256? The count of this number are 256. There are 256 numbers, right? So how do we get this from here? What do we do is, if you see, output encoding is hex lowercase. What does this hex mean? If you are a computer science student, then I already might know how do we convert binary to hexadecimal, right? If you don't, or even if you do, please do pay attention. What do we do? So the conversion of hexadecimal is, hexa is something 16, right? So like, let's say, we use, byte is nothing but 8, right? Octa is 8, right? So hexa is 16. This is what I mean. Octa represents 8, hexa represents 16. That means we have something 16. What is this 16? It is nothing but 0 1 2 3 4 5 6 7 8 9 A B C D E F. So these are the 16 representing numbers. Okay, and same, what goes for octa, I think you can guess it very right. So it's 0 1 2 and till, I mean, it counts 8. Why in hexadecimal after 9 we are not going to 10? Because here, I mean, after 9 we will be going into two numbers, right? So instead of a number, we went into alphabets A B C D E F. So this entire, these are 16 characters, or whatever you can say. What does this represent, right? 16. So how do we convert this to this? So I will take this string here. So we come from, we start from the left. So 0 1 1 0 1 0 0 1. I'm taking just this string and putting it up here. Okay, not here, I mean here. What do we do is, we create group of, this is the actual algorithm of converting binary to hexadecimal. So what do? We take pair of 4. Okay, like this. Let's say we have other number here, let's say so on. So we will make 4 pairs, right? So this 256 bits, which is nothing but characters, get divided by 4. Why 4? Because, I mean, each pair is 4, right? So this will create 64 groups. Why? Because 256 divided by 4 is 64. So this will create 64 groups. So like this is a group, right? So 64 groups like this will get created. Now, after this group is created, we calculate the binary, or let's say the decimal representation of this particular binary number. How do we do that? Binary to decimal conversion is nothing but the number multiplied by 2 to the power, to its positions power. What is this position? This is 0, right? So 0 plus 1 multiplied by its multiplied by 2, so this is plus to its power, which is nothing but 1, right? Plus this 1, so 1 multiplied by 2, its position 2, plus 0 multiplied by 2 to its position 3. So the output is, let's say, 2 2 to the power 0 is 1 multiplied by 0, so we have a 0 here, plus 2 to the power 1 is 2, so 2 into 1 is 2, plus 2 to the power 2 is 2 to the 4, plus into 1, so which is 4, plus anything multiplied by 0 will be 0. So the plus of this all number is 6, right? So this is, if I'm not wrong, representation by decimal representation of sorry, this is a binary representation of digital of number 6. So once we get 6, what we do, we start from here and we count 1, 2, 3, 4, 5, 6. So this is the number. So hence the hexadecimal representation of this particular thing is 5. I might be wrong. I'm getting a bit confused here. Let me do one thing. Binary to decimal, right? Binary to decimal, we will go here and we will enter the binary number, which is, I think, 0110, and the decimal number was 6. Yes, so I think we were right, which was the number 6. And then decimal to hexadecimal, which is 6, and convert, we got 6. Okay, so this was the thing actually. So this starts from 0, not so. Yeah, this is where I was getting confused. So this is 6. How this is 6? So 0, 1, 2, 3, 4, 5, 6, right? So it starts from 0. So what if the number, whatever the decimal representation of something else, let's say it is 13. So it can, let's say 13 is something 6, 7, 8, 9, 10, 11, 12, 13. So D would be the output. So hexadecimal representation of this thing, I'm just taking a guess. Okay, this is not true. So this would be 13, that means D. So you would be asking, what if all the numbers, I mean, why do we have 16 here and why are we taking just combination of 4? Because if you see, what could be the highest number here? What would be the biggest number here? 1, 1, 1, 1, right? Because group of 4. So if you see 1, 1, 1, 1, this would be the biggest number, right? So if you do, which is 2 multiplied by 0, this would be 1, this would be 2 to the 2 to the, sorry, 2 ones are 2, it would be 2. And then if you see, this will be 4, and this would be 3, right? So 2 to the 8. So 8, 4, 2 to the 4, and yeah, 8 plus 4 is 12, 12 plus 2 is 16. No, 8 plus 4 is 12, 12 plus 2 is, let me see, I'm getting a bit confused here. Binary to hexadecimal, binary to decimal, which is 1111, convert, yeah, 15, right? 15. So as this comes to be 15, which we were correct. So 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15. So it starts from 0, right? So 0, 1, 2, 3, and the 15 is here. That's why the largest combination here could only go till decimal number 15, and hence we have 15. Cool. So that was a lot of explanation. What is SHE-256? Not actually SHE-256. What do we represent 256? And how do we get this? So consider that the first 4-digit, the whatever the decimal representation of this, the hash came here, the first 4-digit would be representing 9, and the second 4-digit, second group of 4-digit would be representing D, so which is nothing but coming to be here. Okay, cool. So this is how it works. Now we have talked about SHA, right? A basic understanding. Now we will quickly sum it up, and we will understand about proof of work. What is proof of work? right? And this is nothing but the last topic, but the core fundamentals and the understanding of why do we need such huge machines? Why, what calculations do we do? What thing goes inside? So we will go into online, let's say JS editor. Okay, this is online editor, and I want you to put this code, right? If you are already JS developer, you have bit of JS knowledge here, which is bit required to understand the syntax. We are importing a crypto, let's say, package, right? Then what we are doing, we are just taking a input text. This is an example text, and we are passing this input to this. And what this function is doing is nothing but using this crypto package, creating a hash with this algorithm SHA-256, and then we are using, if you see, we are using this 256 algorithm for this input, right? And we are using this hex thing. What is this hex? We just understood, right? Or we just went through. So this is hex, and it returns and it consoles. If you see, test is returning this thing, right? This is nothing but same what we did here. We just created our own, let's say, code here to. If you see, as we already said, that the same text will always create, if you do remember, the same text will always create the same hash no matter what. It is not like encryption that you paste a text and you get different outputs. So if I, instead of this, I paste this, right? And if I do run, if you see 9092, right? And this is what we, I think, got here, 9092, correct? So this is nothing but the code which actually runs here, uses this SHA-256 algorithm to give this output. Cool. Now, coming to proof of work. Work is, let's break this down. What is work? Work is something, some amount of activity, right? Some amount of task to complete. This is work, right? So, what do people mean by that computers doing work? And what do people mean by proof of work, right? Don't, for first of all, before going through this, don't think about what's the logical behind, logical reason behind this task. Just listen to me and complete, or let's say we will just go through a task, right? what if what if I say, so this is a hash created, right? This is a hash create. what if i say what if I say, write a code to get a hash, which is nothing but this write output, right? This hash that starts with 4 zeros. That means the output here should start with 1 2 3 4, and then whatever number you do, right? Like this. Okay, not space here, whatever number. So but the initial 4 digits should be 0. What would you do? The basic thing what in coding we can iterate from is, one of the very basic thing is numbers, right? We can iterate from numbers. Let's say start with 0, and then we can create a hash. It is very easy. I mean, you don't need a string. You can also give it a string. I mean, not a string. You need a 0, right? You need a 0. You need a string, but any length would work. If I do, you will get a hash, right? So for 0, it's 5f something, right? For 1, it will be something else, correct? So we can iterate through numbers and get a output. And I want you to give me the first output, or let's say the first number starting from 0, that gives us a hash that start with 40. Cool. What we can do here, right? What we can do here is nothing but create a function. Okay, we already have a function, right? What we can do is do a start number, right? We'll start with here. Just give me a moment. Um, yeah. So yeah, we can do, let's say, not a let. We can do a number. We can do a let num is equal to 0. And now what we can do, while true, right? I hope you have a bit of experience with JS. This would be really helpful here. What we will do is input string is, we need a string, right, to create a hash. So what we will do, we will create this number to string, right, which is to string, we are converting this number to a string. Why? We need a string to create a hash. We can't use a number directly. Now, what we will do, we will use this hash, right? We will create this hash, but from what will we create this hash? Now we won't use the input. What we will use, will use the input string, right? As soon as we get the hash, we will check if the hash starts with what is the number we wanted to check for. We will check for 1 2 3 4. Okay, if the number or the hash what we get starts with 4 zeros, what we will do is we will also let's say we will return the hash, or we will, let's say, let res is equal to 0. Okay, sorry for this. And what we will do, res is equal to hash, and then we will do a break. So we are breaking out of this loop, and then from here we will not return the hash, we will return the res. So if I run this, I hope there is no code error here. This is taking a lot of time. If you see, right, index timeout 7. So this took more than 7 seconds. We will see. If you see, initially when we created a hash, it gave us output very fast, but now it took a lot of time, right? So I will reduce the number of, let's say now we want the initial hash to start with just 0, right? Just 0. Let me also include a return statement here. Not return, I think I will break. Yeah, right. Let it run. Command failed. What if with 1? Run. Okay, this should not take that much of a time. While true, num. Okay. Got this. We did a very huge mistake. Num plus plus, and now it should run. Res is equal to hash run. Okay. So now if you see, we got a hash that starts with 1 0, but it took, let's say, 1 or 2 seconds. I will increase the 0 from 1 to, let's say, 3. I need 3 zeros. Now if you see the time taken to find the hash with starting with just 1 0, and the time taken to calculate the hash with start with 3 0, the difference would be huge, right? It took some fraction of more time. But now if I go, let's say, 4 zeros, see, it took, now I will, to show a difference, I would go 1 2, let's say, 6 zeros. See, the time increase, right? The difference between finding a hash, the first hash, from 1 0 to 6 0 is bit of let's say hard, right? Because we need more combination, we need to go more iteration. So if I increase, let's say, 1 2 3 4 more, this will take more time, and this might also go into timeout. See, it is taking a lot of time and it went into timeout. So this is something, this is a calculation, right? This is a calculation. Why do we need this calculation? This is nothing but that, let's say, this algorithm to find, let's say, more number of zeros, starting with more number of zeros. The more zero you add here, the more time it will take. I think it will take. I hope this makes sense, right? So let's continue. Let's say now, so I did say this, right? Let's say now if I say to find a, a code, or let's say if I say find a number, okay, I'm saying find a number to get hash which starts with 4 zeros, and this input has a string, has a prefix, sorry. What do I mean by this is, now what I'm saying, initially we just ran a loop from 0. Now what I'm saying, I will also have a prefix. What is prefix? Prefix is something which gets added to the beginning. So now the input string won't be just number plus to string. It will be prefix plus this. So what I'm saying, now the first iteration was the iteration was 0, sorry, 0 1, array yaar, 1 2 and so on, right? But now what I'm saying, to find a string, a input string that would have a fixed prefix, let's say test, or let's say web3. So now it won't be just a number, it will be uh, the number plus a prefix, right? Now with this string, I want you to find a hash that starts with, let's say, 4 zeros here, right? So how will we do that? We will add this prefix to this here, and this will become prefix plus 0 and something like that, right? So now if I run this loop, web3, okay, sorry. See, now I got a number, right? So I don't want the hash here. What I want is, I want the number. Now I want to know that what number I can add to web3, what number I can add to here, what number I can add to web3 that will give me a hash which starts with 4 zeros, right? So I will comment this out, run this. So 5610 is a number, 5610 number which I add to web3 string will give me a hash of which starts with 40. We will verify it up here. So if I add web3 plus this here, okay, web3 plus 5610, I think it should be 09. Okay, क्या दिक्कत हो गई? Okay, let's see. Console.log input string undefined. Okay, okay, I'm not passing here web3 and run. So if I add 84863 to web3, it should give me a hash. It should give me a hash that starts with 40, right? See, it gave me hash with 40, right? So this is the number. We need to find a number. Now, please try to connect the dots. What did I say? I will give you a prefix. I will give you a string prefix. That is nothing but same plain string. And I want you to find a number which if I add to this string will give me a hash which starts with 40. Why are we going behind this 4 zeros? I will come back to this later. Okay. The last thing what I want you to find is, I hope you understand now, is, let's say I, instead of this string, what if I say I have a transaction detail? Okay, we are coming to the end. What if I say we have a transaction detail? What is transaction detail? Let's say person 1 sends 100 Bitcoin to person 2. What is this person 1? What is this person 2? It won't be a normal string. We will talk about this later. Now consider web3. Instead of web3, I'm saying find me what number can I add to this particular transaction string, which will give me which will give me hash of 4, starts with 4 zeros, right? So I will take this, I will give this, I will do a run, and this will do something, and it says this, right? So this is a number. If I add to this particular string, so entire string, so what is this? This is nothing but the message which is still here, and then if I add this number to this will give me 40. Now, coming to the main point. This is nothing but proof of work. How? How? Why is this proof of work? There are certain things that you might have heard till now in the, let's say, crypto industry, or whenever if you did bit of trading, that the complexity is high. The miners are getting very less incentive, and they are doing a lot of work to get lot of work to get very less amount of Bitcoin. The complexity in the system is high. What do they mean? If, let's say, if I want to find a hash with the number of zeros are 4, right? This means this will take, let's say, n time, right? Let's say n is equal to 7. But if I increase the zero, let's say from 4 to 6, and if I run this, this will take much more time, and this might also go into timeout. I think you can see into timeout. It went into timeout, but I it reduced the zero. The time is less. Now it did compute in under 7 seconds. What does this mean? The number of zero I do increase here. The more complex the system gets, the more time the miners or the system will take to find a number. And this number, finding a number, is nothing but work, right? It is not easy that someone can come and find a hash or just write a random hash that starts with 50. No. Why? Because that has to attach to this particular string, and then it should make a hash that has initial 5 zeros, 4 zeros, whatever. So the number of zero increases, the complexity of the system increases, and this is the work that the miners do. The miners nothing but constantly solves a question like this, where there's a sender that says that, hey, I want, there's a transaction message. What is that message? We will come to that in the later video. They give a message to this miner. Okay, this is not exactly what happened, but try to understand. This is a message. The transaction message gets sent to the miner. The miner, what they do, they nothing but find a hash. The Bitcoin entire blockchain, or the Bitcoin network, sets the starting number of zeros based on the current market. How does this get calculated? We will come back to this later. Okay, so let's say the market is very good. That means the number of zero will be bit less. The market is bad. The miners are taking more work. The miner have to do more work to find Bitcoins. So what did they do? They increase the number of zeros here. Why? Because this gets more hard to find the hash number. And so this message, what the miners do, what the machines do, they find a number, which is this number we found for, let's say, this message, that will equate to a hash that will starts with this n number of zeros, and this n number of zero is set by the blockchain network. Cool. So a lot of jargons here, a lot of, I mean, I know this is nothing but a foolish, or let's say, calculation which goes very baseless, you might think, but this is nothing but the proof of work thing, the people, what the people talk about, and this is nothing but the complexity. The more zero increases, the more complexity increases, because it takes more times for the miners to find Bitcoin, or to get the Bitcoin, right? How the miners get Bitcoin, we'll talk about in the next video. Cool. So yeah, thank you so much. I hope you liked this. This was a very long video. From the next video, we will talk about how the Bitcoin, or how the network transfers, or how the miners come into the picture, what will happen. Cool. Thank you.